All right, so here we're trying to find relative extrema. Again, the very first thing we want to do is think about our domain of the function. It is not all real numbers because we have a fraction, or potentially it could not be all real numbers because we have a fraction. So to find the domain, we're going to set the denominator not equal to 0. So that's going to be v squared plus 5 not equal to 0. Solving this, I will subtract 5 from both sides, get a negative 5 on the right, and then take the square root of both sides to get v cannot be plus or minus, because of the square, imaginary number I square root 5. Now, where did that imaginary number come from? It came from the square root of a negative would go to I. So the square root of negative becomes an imaginary number I. Now, this is significant because what this means is that we are going to ignore this domain restriction. The idea is we're only putting in real inputs. And so when I get this imaginary number, I'm going to completely ignore it. I'm not going to say it's a domain restriction. And so because we ignore the imaginary numbers, there are no domain restrictions. And that means that our domain is the real number system. So every number is going to be interior to the domain. All right, so that is part one, is just thinking about what is the domain. That is part of the critical number process. Then we need to take our derivative. To take our derivative, we notice we have a variable over a variable. So that is going to require the quotient rule. So here I'm trying to find those critical numbers. I need to take my derivative. To take the quotient rule into account, I will have my negative 21v and then my v squared plus 5. The negative 21 is a linear term, so it goes to the coefficient. V squared drops down to 2v, and then the plus 5 goes to 0. Remember that for the quotient rule, this is always over the bottom squared. So we will have that our derivative is equal to, let me take the derivative first, it's going to be equal to negative 21 times v squared plus 5 minus negative 21v times 2v. And that's all over the bottom squared. So we plug it in with parentheses. Here I'm really being careful about the parentheses because obviously there's more going on than just times 1. And then our next step is to remove those parentheses. So the negative 21 is going to get distributed. That will become a negative 21v squared. And then here I'm just taking negative 21 times the 5. That is where my negative 105 is coming from. Then we have our minus sign. And then here you'll notice that this is just one term multiplied by one term. So we don't need to do any sort of distributing. We just need to multiply it all together. So take negative 21 times 2 to get negative 42. And then the v to the first becomes a v squared. And then this is all over my v squared plus 5 quantity squared. This double negative becomes a positive. And then combine our like terms. So that gives us negative 21 v squared. That is a like term with this 42 v squared. So taking negative 21 plus the 42 will give us a positive 21 v squared minus 105 over v squared plus 5 squared. And that's our simplified derivative. From that simplified derivative, we are then going to set the numerator equal to 0 and the denominator equal to 0. So I'm going to go over here to the next page and do that. So I will have 21v squared minus 105 equal to 0. And then the v squared plus 5 squared equal to 0. All right, so for this first equation, I need to undo PEMDAS. To undo PEMDAS, I will simply add the 105 to both sides, and that gives us 21v squared equals 105. And then continuing to undo PEMDAS, I undid addition and subtraction. Now I need to undo multiplication and division. So divide by 21. So take 105 divided by 21 gives you 5 equals v squared. Now to undo this exponent of 2, remember that that has two answers. So we're going to take square root of both sides, and that will give us v is plus or minus square root 5. Now on this right hand side here where we set the denominator equal to 0, to undo the square power we're simply going to take the square root of both sides, and that gives us v squared plus 5 equals 0. You guys, technically this step you can skip. Every time you have that parentheses squared, you're just going to take whatever is inside of the parentheses and set equal to 0. So it's not like a huge deal to have that square root or not. You just parentheses squared is going to be that whatever's inside of that quantity. And then subtract 5 from both sides. We get v squared equals negative 5. And then take the square root of both sides. We get v is equal to plus or minus, again, that negative underneath the square root becomes an imaginary number I, and then square root 5. Now, what do we always do with imaginary numbers? When we're talking about functions and graphing them, we ignore the imaginary number. So we did all this really great work, but nothing's going to come from it. We're just going to ignore it because it is an imaginary number. So the only two critical numbers we have are plus or minus square root 5. Now remember,